FPGAs are a particular family of integrated circuits intended for custom hardware implementation, with the key property of being able of being configured after having been manufactured, for an infinite number of times. Configuring an FPGA means changing its functionalities to support a new application, and it's equal to having some new pieces of hardware mapped on the FPGA chip, having to implement a completely new functionality. In other words, FPGAs make it possible to have custom-designed high-density hardware in an electronic circuit, with the added bonus of having the possibility of changing it whenever there is the need, even while the whole application is still running. Another design language, such as VHDL or Verilog, is used to describe the functionality to be implemented on the device. Then, the design software of the device manufacturer translates the description of the hardware into a configuration file for the device that can be downloaded on it. These software tools are analogs to those employed in ASIC chip design, in the sense that they convert a hardware specification into an actual netlist that can be synthesized, placed, and routed on an actual pieces of hardware such as an ASIC or an FPGA. The flexibility of having custom adaptable hardware in an application is the factor that has determined the popularity of FPGA devices in a broad range of fields. If the FPGA is paired with a general-purpose processor, for example, the most demanding section of the software can be translated into hardware cores that accelerate program execution, yielding notable speed-ups in the overall execution, especially when software sections executed serially on the processor can be translated into hardware that can exploit the parallelism of the algorithm. We are now going to briefly discuss the distinctive features of FPGAs, in particular to clarify how they can implement custom hardware via their reconfiguration. We know that there are several companies producing FPGAs, but the devices we are going to focus the majority of our example throughout this course are the ones manufactured by Xilinx. Within this context, the following architectural details, even if they can be generally applied to other different devices, apply to the chips produced by Xilinx. The three main building blocks of an FPGA are configurable logic blocks, I/O blocks, and communication resources.